Hey kids, I know a lot of you are out today for a field trip, so we're going to go over what you missed in class. And today we went over a lot about vertex form. First, I want you to visually see the difference between a vertex and just any point, okay? So the vertex, you know, is the turning point of the graph, and let's say this one is -1, -3. In an ordered pair, that -1 is our x, the -3 is our y. Same thing for this 3, 5, it's x, y. This one is x, y. And this one is also x, y. And so the problem arises where the vertex is a very special point, but it's given the same x and y, x and y, x and y. And so to differentiate or to make it known that this point is a very special point, instead of writing x, y, we give it the name h, k. So h, k just means that whatever that point is, that's our vertex. So it's a very, very special one. Whereas x and y could be any point. It could be this point, it could be this point, it could be this point, doesn't matter. So today what we went over was vertex form. Because in vertex form you have y, x, h, and k, where h and k refer to that vertex. It's that very special point. And y and x could be any point. It could be anywhere that's not the vertex, all right? Now, you've got notes written for you, so when you come into class tomorrow, it explains it. Now, if you know your vertex and a point, you can actually solve for A, which tells us what the graph looks like. Does it open up or does it open down? And we'll get into that. And once you solve for A, then you can write the equation of that parabola in vertex form. So you can write the equation in vertex form. And it's called vertex form because we use the vertex in the equation. So let's say that I have the vertex 1, -2, and just any point I picked out on that line, we're going to call it -3 and 7. The very first thing I would do is I would label my points. So my vertex is h, k, and then my point is x and y. And from here you are going to substitute those numbers into the spots that our letters were. So in my y spot, I'm going to use my 7 because that's the y that I have out of the points, equals a. I'm going to leave a because I need to figure that value out. Instead of x, I'm going to use the number -3. For my h, I'm going to use a 1. And for my k, I'm going to use a -2. Now let's clean this up a little bit because we would never really write plus a -2, right? So for our next step, and I'm going to use a different pen, I'm going to clean it up. I'm going to have 7 equals a times -3 minus 1 squared minus 2. Now I want you to think back to PEMDAS because we're going to start solving for a. The very first thing I need to do is my parentheses. So -3 minus another 1 is going to give me a -4. And I'll bring everything else down. After I deal with what's inside my parentheses, I need to work with my exponents. So I'm going to write this out. -4 squared is not -4 times 2. It is -4 times itself, or -4 twice. Minus 2, bringing down the 7. So in my next step, I should really have 7 equals a times positive 16, because a negative times a negative gives me a positive, minus 2. Do we ever write our coefficient behind our variable? No. So this should really be rewritten as 7 equals 16 times a minus 2. Now from here, y'all, this is just a two-step equation. I'm going to add 2 to the other side, so that way all my Variables on one side, all my numbers or my constants are on the other. 7 plus 2 is 9 equals 16a. To get a all alone, I'm going to divide by 16, and I'm left with 9 over 16. Now, this doesn't simplify, but if it did, you're going to want to simplify. So now I know my a. I also know my h and my k, or my vertex, so I can plug it in to my equation in vertex form. And I'm going to leave my y because it could be any y. It doesn't necessarily have to be this point. Remember, it could be any of these points on that graph. So I'm going to leave y equals 9 over 16 for my a, because I solved it, times, again, x, because it could be any x, minus 1, because that's my h and my vertex, squared. Should I write plus a negative 2 for my k? No, I just need to write minus 2, because plus a negative is going to be a minus sign anyway. And so this is my equation in vertex form for a parabola that has the vertex of 1, negative 2, and passes through the point negative 3, 7. And from this equation, I could find all my points just by plugging in my x values and solving for the y. So another thing we talked about in class today is if your a is positive, like this one is, then your parabola is going to open up, okay? So then your parabola opens up. And this means that it actually has a minimum value, or that vertex would be the minimum. Now, if your a is negative, it means your parabola opens down. So then you would have a maximum value. All right, that's what we went over today in class. We did not touch the standard form, but for your a in standard form, it's the same rule. If it's positive, it's going to open up. If it's negative, it'll open down. Let's try an example that we did together, okay? So on the back, I made students rewrite the equation y equals a times x minus h squared plus k. And again, we're going to be filling in our y, our x, our h, and our k based off of the information that we're given. So I'm going to go ahead and draw those little boxes so you can see that I'm just plugging in numbers into those spots. All right, so in question 1, it says, what quadratic function in vertex form, remember we want the equation, can be represented by the graph that has a vertex at negative 3, negative 7, and passes through the point negative 1, negative 10. The very first thing I'm going to do is label my points, h and k. That's my special one, and it tells me it's the vertex. Your vertex is not always the first point, so you need to read. And then it tells me that it passes through just any old point at negative 1, 10, so that's just my x and my y. Now from here, I'm going to plug those values in to my equation. So my y is negative 10, so I'm going to write a negative 10. My x is a negative 1, so I'll plug in a negative 1. My h is a negative 3, so I'll plug in a negative 3. And my k is a negative 7. And I'm going to start cleaning this guy up, all right? So I'm going to rewrite it. Negative 10 equals a. Negative 1 plus a negative 3 is the same as negative 1. Minus a negative 3 is the same as plus 3. I got ahead of myself, squared, because minus a negative turns into a plus sign. And then plus a negative 7, I would never write that. I would just write minus 7. So once I have my equation set, I can start going through my order of operations in PEMDAS to find a. So the very first thing I do is I'm going to work with what's in that parentheses. Negative 1 plus 3 is 2, and then I'm going to bring everything else down. I'm going to then do my exponents. 2 squared is the same as 2 times 2, so that is going to be 4 minus 7 minus 10a. Now again, I never write this as a times 4. It's always 4a. Your coefficient always goes in front of your variable. So I'm going to rewrite it just so that way it's clear. And I've got negative 10 equals 4a minus 7. And from here, it's just a two-step equation. Step 1, I'm going to add 7 to the other side. And I will get a negative 3 equals 4a. And then step 2, divide by 4, so I get my a all alone. And so my a is negative 3/4. Since my a is negative, does this graph open up or down? It opens down. So once I know my a and I know my k, once I know my a and I know my k, I can go ahead and plug it back into my equation for vertex form. And in vertex form, I'm only using the vertex. I'm not using the other point, whatever it is. It's vertex form because I use my vertex. So it's going to be y equals, my a is negative 3/4 x minus, and I'm going to put minus a negative just for this step, squared, plus that negative 7 for my k. Now, I would never write it with this many signs, so my final answer should be y equals negative 3/4 x minus a negative turns into plus 3 squared, and then that plus that negative 7 turns into that minus 7. And that would be my final answer. Now, at the end of this, I had students also talk about, well, how are h and k different than x and y? And what I want you to think about is h and k is a vertex, and x and y is just any point. A new word that you might want to know, we can say instead of any point, we can just say an arbitrary point, meaning like any point we choose, it means the same thing, or we can just stick with any point. Now, that's how they're different, is that h and k is a very special point. It's our vertex, x, y is just any point. They're similar in that they are both still points on a graph, okay? They're going to be someplace on the line. So they're both points. And that's what we went over today in class. Students are asked to finish the last 3 because I realize it does take you some time to find your A and then write the final equation. On Canvas, I'm going to post the key from this, and it's got step by step so you can check your steps to make sure you're getting it right. All right, good luck.